Today we are going to do two things. We are going to build an alien music generator and we'll put it into a human musical context, a bit more human at least. Okay, Krell music generator. Let's create a looping envelope follower. I call the designer loop here. I create an envelope follower, trigger to gate, and we trigger this trigger to gate node with a trigger, and the time this will take to go will support the attack phase. And whenever this gate here goes low or down, we will fire a trigger. So we call this gate, multiply by the change like this, and output a trigger. So if this goes down, we trigger this here, and if this goes down, we trigger the original guy. And this modulation output is going to go into the release modulation, and all the modulations that are cranked up. We only need to get a trigger inside here. So this is a trigger here, and we also need a gate. Let me recreate this here. So this is the lowest input plug, and this is going to be the attack input, and this is going to be the release input, and this is going to be the envelope output, and I create an output here as well, and this is going to be the cycle output. And actually, if I did not do anything wrong, this should work. So let's create one node for attack and release, create a scope here, gain in, and let's test this if it works. It looks like okay. And does the cycle work? Yeah. So we can trigger stuff, and we can create nice envelopes. That's fine. Okay. So the idea is to modulate a sine wave for each cycle with a different attack and release time. So I create a simple sine wave here with a constant pitch and plug in this envelope here. And oh, I deleted the controls from this here. So sorry, this was mono. So we will modulate this and the pitch of the sine wave as well. And it's going to be fairly simple from this point on. So we will use the cycle trigger and create some random nodes here. And to randomize the pitch, we just plug this in. Actually, I create a node for this. So pitch random, and here we receive a trigger. We set the minimum like 8 and the maximum like 78 maybe, and output an integer value. And if I plug this in, we will hear a different pitch on each cycle. I deleted the control once again. And this is nice. So we have the pitch control, and we also want to randomize the attack release ratio. So first we want to randomize the time cycle takes, and then we randomize also the ratio of how much of it is attack and how much is release. But this won't be complicated. So random loop, 2 O's and 1 P, and here we will receive the trigger and create a random value. So attack time and release time are going to be the same. So this is the cycle time, and it can go from, let's say, 10 milliseconds to 2000 milliseconds. And another randomizer where we create a value between 0 and 1. And here we multiply this by the output of the second randomizer, and here by the inverse of that randomizer. And this is going to be the attack, and this is going to be the release time. So we can plug in the cycle here and simply paste them there. And this should actually work. Yeah, 2000 is maybe too much. And yeah, maybe we can balance this a bit. So let's create this between 0 and 1 as well. And take this to the power of, let's say, 4. But you know what? Not even like the power, just like this. So using a custom function, we can easily tell how much we want from the higher values and the lower ones. And we can also scale it like in between 2000 and 10. This is faster. And then this goes into the A input slots of these multipliers. Okay, 10 is maybe too low. This is nice. And by the pitch randomizer, let's go from 20. Okay, this is fine. And we want to create another sine oscillator, create another random pitch for it. And this will have a constant volume. And what we are going to do is to multiply these two sine waves. Nice. And we can also create some FM here. And this is not going to be a full-blown FM thing, but it will work. And even if it's a bit glitchy, that won't make sense, because that's what we want. This is it. And this goes into the FM input, this goes into the pitch input, and pitch like this. And this starts to sound like the original Krell. And what we can still do is to introduce some filters. And for that, I'm going to use filter SVF, so a state variable, like this. And let's create another loop here, because why not? And then let's randomize the nothing, just prescale this from 0 and 1 to something like this, maybe. Oh, also randomize this. Sorry, like this. Cycle comes in, this to go in there. And this whole thing will sound a lot better with reverb, like this. And we can still enhance this by using a wavetable oscillator. Let's give it the same pitch as the sine wave gets. And simply mix it. So I create a mixer, plug this in, output will go into the filter, sorry, and yeah, like this. And let's use another set. I think, yeah, this basic waves is going to be fine. And it will be controlled by the filters. And what if we don't use the FM? Yeah, and this is all nice, and this can be extended further with wave shapers and stuff. So I really can go more in depth, but I think the principle is not. It can be understood. Okay, that's the word I'm looking for. But I want to change the randomness a bit because of let's say here I want to be able to use these in a song maybe, and then I need a value that's always reusable. So I like randomness, but in this way I have to record this stuff and use it as sample, and I'm not using samples that much. So I have to come up with something, and I create a table with an LFO noise and an incrementer that will start at -1 and increment by 1. And I put a trigger there, and this goes into the right input. And now I have a table with random values, and I can reuse this here. Let's say in the random loop, I can create a clock, and this clock will be able to drive the read input, and I will modulo this by 63. So each time a trigger comes in, we will read out the value from the array. And I can make this clock run in pretty much the sync from the DAW, like using a value that's not an integer number. So we will get pretty much random value out of this, but each time we replay the sequence on the same spot, we will have the same value. So I know this looks a bit complex, but as soon as we put this into a designer, it will be clear. And I will call this random array. And this just needs a trigger as input and the transport run. I call this out like this. So yeah, trigger comes in and the value between 0 and 1 goes out. So we can plug this here. And another one can come from there to here. Like this. So this way things will be a bit more predictable, but still stay random. And yeah, do the same for pitch. So I copy this random array. And here we need to remap, so the minimum is this and that. So we have a rescaler node here, and we know that the minimum is 0, the maximum is 1, then we can do it like this without losing any features that we had before. Yeah, this is nice. And yeah, another random pitch, then it's going to be like this. So this should sound the same. Okay, this moves too slow maybe, so let's... And even if we do this, that's not gonna hurt anyone. And do the same in the pitch. And here as well. Okay, this looks like it's working. Now all I want to do is to use this with a gate. And yeah, to show an example on how this can work fine is probably to, yeah, let's replace this here. Instead of a MIDI note, I create a cone here for the gate and for the trigger, and we use a clock. And I truncate the clock and modulo it by, let's say, 4. And if the clock is above, let's say, 2, then I will output 1, as it will be 0. So this was the gate. So this is a gate signal now. And let's multiply this by the change. And now we have a trigger as well. So I stop, reset the clock. Oh, I need to put a variable here. So I stop, reset the clock, and start. Let's remember this. I start again. And the sound is the same. And this is especially good if you have some drums running. So I activated now a drum track from another track of mine. And this will be the decoration part. Okay, that's it for today. I hope you had fun. Thanks for watching. Bye bye.